This video is to show you the steps and the answers that belong with our MSTEP setB warm-up. So this is really a warm-up process, which usually we would check together in class, but with me gone, it's going to be helpful maybe for you to see kind of some thinking at the board and make some changes accordingly so that you have some good answers and some good recorded work. If you notice, today, day one, actually has two problems. We are looking at sample number 7 and sample number 8. So let's go ahead and start here. Sample number 7, and of course your name, date, and hour should be on the top. So please fill these things in properly so that I can give you credit for the things you've done. Next, sample number 7 asked us to select all equations. This is a big hint, it's also bolded, all equations that have x equals 3 as a solution. Now, the work that you might show me here could be a little bit different. If you were in my 7th grade math class, you already know how to show inverse operations. So perhaps you are working on those now to prove your thinking. So inverse operations, this is a great idea, hint, hint, wink, wink, red hour. But let's pretend that you haven't used inverse operations before. Maybe you're in my 6th grade math class, or maybe you're going to treat this as a different type of problem where we get to evaluate an expression. So when we're evaluating an expression, or in this case, I'm sorry, an equation, because there's an equal sign, we're going to use some substitution. We're going to actually take out the variables and put in the value. So if you take a peek, this x equals 3 is pretty important. I'm going to try it in each of these problems. So to take this first problem, it originally says x plus 7 equals 10. Well, if I were to substitute, if I replace this x with a 3, because they say that's the value I want to use for x today, my question to you would be, is 3 plus 7 equal to 10? The answer is yes, it checks out. So this is definitely one possible answer. So we want to shade it in, probably do some little better shading than this. Again, on the MSTEP, we're not doing a paper pencil copy, but one day if you're back to paper pencil, you need to know that shading matters. So let's try the next one. The next equation they give us is 3 plus x equals 3. Well, I'm going to try the same strategy to evaluate the equation or to use substitution. So in a minute, I'm going to take out this x and put in a 3 because they told me x equals 3 each time. Let's try it out. 3 plus 3 equals 3. Well, would this be a true statement? What is 3 plus 3? 6. Does 6 equal 3? Indeed, it does not. This does not check out. This is not a true statement. So if I had my cross-off tool, I'd probably use it right about now. This one does not work. We want to try the same idea with these other they're actually equations. I keep calling them expressions, I'm sorry. With these other two equations. So the next one I see here says x times 3 equals 1. We're going to try the same idea of substitution. I'm going to take out the x and put in the 3 that they told me to use each time. And remember this dot here, it's kind of floating. It's a little bit higher than a decimal for sure, so that you know we were talking about multiplication. Well, when I do this substitution, or I go to evaluate what is 3 times 3, hopefully you know that's 9. And here we end up with 9 equals 1. Was that a true statement? No, 9 can never be the same as 1. This does not check out. Again, if I had my cross-off tool, I'd definitely get rid of this option. We need to try one more. And I'm kind of running out of space here, but I'm going to go this direction. And I'm going to show you 4 times x equals 12. And again, we're going to try this idea of evaluating the equation or substituting. So let's keep everything the same, but take out the x and put in a 3. My question to you is, what is 4 times 3? Hopefully you'd say 12. And in this case, it checks out. You found another good possibility. There were 2 good answers. And there's a hint here. Sometimes it says select all equations or more than one answer. So that's what we've done. Hopefully you've made some changes here for sample number 7. We're going to fast forward to sample number 8. Here with sample number 8, they say a recipe requires 3/4 cup of nuts for 1 cake. Enter the maximum number of cakes that can be made using 7.5 cups of nuts. Well, if I know that this recipe requires 3/4 of a cup to make 1 cake, off to the side I might remind myself here, 1 cake goes with 3/4 of a cup. Well, if you notice, it says I want to figure out the maximum number of cakes. Really, that means I want to figure out the most cakes I can make. And they're giving me a different amount of nuts. They're giving me 7½ cups. So I'm going to use a 7½. And if you notice, cakes could kind of be here on the left in my organization compared to nuts as an ingredient on the right. So I'm going to change this to 7½ cups. And notice I'm putting it on the right side of my organizer or my thinking because that goes with the ingredients. And I'm trying to figure out how many cakes that might make. Well, one way to do this would be to say 3/4 times something will get me to 7½. But it's kind of a mystery to me what I would use, multiplying by a fraction to get there. So is there another way we could do that? Could we move in the reverse? If I know the total ingredient that I have to work with, the total amount or quantity, could I start splitting it into groups of 3/4? Oh, the opposite of multiplying is dividing. I think this might be a better option, so let's kind of go this direction. What you could do for me is really use this workspace over here. We could really say this is 7½ and I am dividing or splitting it into groups of 3/4 because every single cake requires that amount. And I'm trying to figure out how many cakes I'm going to get. Well, if you remember from our previous unit of study, when I'm given this mixed number, it's hard to work with unless I turn it into an improper fraction. I somehow have to get this whole number included, don't I? So if I were to think of 7 whole cookies or pizzas or whatever they might be, split into halves, that would be 2 halves in each one. So 7 times 2 gets me 14. Don't forget that we need to add on that extra piece or that extra part in the numerator. So 14 plus 1 gets me 15. And we get to keep the denominator. Sometimes we affectionately call this MAC. We're multiplying, adding, and keeping our denominator. Well, I might just do a rewrite step for you in this situation. Sometimes we don't need to do that. We move straight into the next step. But I think it's a good idea whenever we have a mixed number to do this rewrite step, meaning I still have division happening here. Well, what would you do next? Please be cautious. It's been a while since we've seen these. I hope you remember we need to move to a keep, change, flip. We do not want to cross simplify until we're beep in multiplication mode. So I will keep the 15, I'll keep the 15 halves, easy for me to say, hard for me to write. I will change from division to multiplication, and my flip is also known as a reciprocal, meaning these numerators and denominators change position or order. I am really ready to complete this problem, but I noticed something fabulous. Take a look at this 2 and this 4. Do you see how they might cross simplify? Oh, they both divide by 2. 2 goes into 4 twice, and 2 goes into 2 once. Oh, but just a minute. Is there more? Take a look at this 15 in the numerator and this 3 and the adjacent denominator. What number divides nicely into 15 and 3? Hopefully you're thinking they both factor or divide by 3. Well, 3 goes into 15 5 times, 3 goes into 3 1 time, and we're really ready to multiply straight across. Some people prefer to do a rewrite step here, so they might instead say 5/1 times 2/1 before finding a final answer. Well, what is 5 times 2 in your numerator? 10. What is 1 times 1 in your denominator? 1. And this is kind of a strange looking answer. In fact, it's an improper fraction, and hopefully you recognize that if it's written over 1, that is the same as a whole number of 10. The numerator becomes our whole number. You've just found me an awesome answer. We were trying to figure out how many cakes were possible. Looks like the answer is 10. Now the thing that's interesting here is it looks like they're going to make you use this template or this this tool in some way, shape, or form. It's not quite an equation builder, but it looks like it's kind of our way of inputting an answer. So in this case, we're hoping that you're able to place a 10 here, and if they allow you to use the keyboard, you'll want to label. Now in the past, they haven't allowed us to do that, so even though your teacher has taught you label, 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 perhaps the MSTEP won't let you. So we're looking for an answer of 10 cakes. So now over here, it says what tools could you use? Well, what tools would make sense for this last problem? I don't know. Maybe you would care to use a calculator to kind of do your facts or your simplification. So I can see a calculator being a possibility. It would help you with your facts. Any other tools might be useful? Well, maybe if I go back to that previous problem, I could talk about the cross-off tool. So that helps me eliminate any bad answers, any bad choices, right? Okay. Any other tools we might use? Well, actually, on both of them, I can see a real purpose for using the highlighter. Remember, the things that we highlight are not going to be scored, but it will help me find key information. So I'm just going to write key info here so that you can see my thinking. I'm guessing that some of you would argue maybe a line guide would be useful to remember where you are. I'm guessing some of you might like a sticky note, but we get the idea. You need to find me 3 reasonable tools and list how they can be used for these 2 problems. This is where you're supposed to stop for today with my guest teacher, just because I'm hoping to be back the following day, but there are no promises. I'm going to fast forward to the next section. So this would be a good time for our guest teacher to stop the video, unless of course this happens to be Wednesday and we're returning to a second block and we'd like to look at the answers for day 2 instead. So again, just day 1 is all that's expected for Monday and Tuesday, March 12th and March 13th. But if we're talking about Wednesday or Thursday block, well, that's where you would move on to day 2. For that reason, I'm going to record kind of my answers and my thinking for day 2 and day 3, just because I want to have them down in case I cannot be here for you. So if we take a look, sample number 9 on the back side, it says I have 16,536 divided by 24. The only directions say divide. Well, I'm guessing they're not going to give me the calculator on this one. That would just be too nice. So I'm going to actually write out the dividend. Remember, the first number dives in. It's the dividend. Haha. Dividend dives in. And the 24 becomes my divisor. What's nice is I don't have any decimal movement to think about. You notice 24 is already a whole number, so this is good. And if I have to go to decimal land, well, the decimal in my dividend is at the back. So I'll just keep that in mind. All right. Well, let's go ahead and start dividing. You might want to use your multiplication chart today. Again, on the MSTEP, you won't be able to do that, so maybe you just kind of want to give it your best without. Does 24 go into 1? The answer is no. Does it go into 16? If we take the first 2 digits here, we'd still say no. Does 24 go into 165? The answer is absolutely. And if I think of 24 almost being close to 25, kind of like money, kind of count over here, 25, 50, 75, 100, 125. Well, maybe I could get even closer, 150. Next would come 175. 175 looks a little too much, but I kind of am shooting for this amount. So how many groups of 25 is that? 1, 2, 3, 4, 5, 6 groups. So I'm wondering if 6 groups of 24 will get me close. Notice that 6 is going right above the 5 that we're talking about. And what is 6 times 20? Well, that's 120. What's 6 times 4? That's 24 more. So it looks like I'm going to get 144 here. Let's go ahead and subtract. 5 take away 4 is 1, 6 take away 4 is 2, and 1 take away 1 is 0. Ooh, it looks like I got pretty close. I'm pretty impressed. That was a good estimation skill. All right, well, I'm not done yet, and I have another digit that I can bring down. So I want to figure out how many times does 24 go into 213? Well, using the same strategy that I did a minute ago, I didn't get that far, did I? I stopped at 175. Next, we'd have 200, then we'd have 225, which looks like it might be a little too big. Let's shoot for this 200. How many groups of 25 is that? 1, 2, 3, 4, 5, 6, 7, 8 groups of 25. So what if I tried 8 groups of 24? Let's see if we can get close. 8 times 20 is 160. 8 times 4 is 32 more. So I'm thinking off to the side here, I have 160 and 32 more. Oh, I can see that. 192. Let's go ahead and do some subtraction. What's 3 take away 2? 1. And with a little regroup here, 11 take away 9 is 2. And 1 take away 1 is 0. This looks pretty good. I noticed 21 is smaller than 24, and I actually ended up with 21 as my leftover piece, kind of like I did a minute ago. But I have a different digit to bring down this time. I have a 6. I want to figure out how many 24s go into 216. Well, I noticed a minute ago I was pretty close. I had 192. I wonder if I bumped that up a little bit, if I could get close, like to 216. So instead of 8 groups, let's try 9 this time. What is 9 times 20? I hope you'd say 180. And what is 9 times 4? 36 more. So stacking these, kind of thinking in my mind, looks like 0 and 6 is going to get me 6. 8 and 3 more gets me 11. Oh, this is awesome. I actually get 216. There's nothing remaining. I do not have to go to decimal land, although it's a very fun place and sometimes it never ends. It's even better than Disneyland, no doubt. And in this case, I have a final answer. It's a whole number. I really would say 689. Again, we're not working on paper, so you're going to have to use this keypad somehow. You're going to have to enter the answer of 689. Make that a 9. Not sure that's pretty. All right. Those extra zeros up front, not needed. That decimal, probably not needed, although I probably wouldn't count it wrong if it was there. And in this case, it's not a word problem, so I'm not even going to try to label it. This looks like a final answer. Please make any changes you need to for day 2 if you're watching this video to make some corrections to your day 2 warm-up. Oh, and I forgot, we need to talk about our tools. What tools would be helpful on this? Let's be honest, the calculator probably is not an option because we all know how to type this in and we'd all get the same great answer. They're probably going to make you practice some long division and some place value. So what else might be helpful? Well, let's see here. I need to use that keypad, so maybe I'll just write keypad. We don't normally talk about that, but I'm going to have to key in the numbers of my answer. What else will be important? Well, the pointer, of course. The pointer is how you're going to choose the numbers. So it's to click or to choose numbers on a keypad. I'm not sure if I need a highlighter in this case. I'm not sure if I need a sticky note in this case. Gosh, I'm struggling to find a third tool. I'm wondering if as a class you might discuss it. Maybe you'll come up with something that I'm not thinking about at this very moment. Lots of students, I guess, have referred me to the eraser. Have to play with that a little bit in our MSTEP tools and see what it will do. But maybe it would help me to back up if I did something wrong. Maybe if I'm writing or highlighting or something here, I might have to erase. So I'll just write if I need to make changes. I feel like I'm struggling to find a third tool. Again, maybe as a class you'll come up with something better than what I thought of. All right. This would be a great spot to stop if you are in our Wednesday, Thursday block and you're checking day 2. Again, you don't need the whole video, you're only checking day 2. But because I don't know when I'll be back, I'm going to go ahead and record day 3. So if you happen to be my guest teacher or you happen to be making some changes, please know that this day 3 is probably going to happen on Friday. That would be March 16th. So this is more of a Friday plan. All right, let's pretend it's Friday, March 16th. Let's pretend that you need to do some checking to see how this is going. Well, we're on sample number 10 then. It says select all the expressions that are equivalent to 8 times the quantity of t plus 4. I'll be very honest with you, I'm kind of surprised that this is considered 6th grade content. My 7th grade students have seen this, my 6th grade students have not, and we don't tend to teach it in this grade level. So this will be interesting. I think we could try this the same way we did earlier. Maybe, so that you're familiar with evaluation and substitution, we could handle it that way, and that might be kind of familiar then. So let's approach it that way. So if you're in my red hour and you have a different plan of attack, maybe you're going to handle this with distribution. Red hour distribution sounds great. Okay, you know how to do that. That'll work. In any hour, we can work on evaluating or substituting. These are expressions, and we're looking for something that's equivalent. So I would probably use a highlighter right about now and say I'm looking for something equivalent to this. Well, yikes. I'm not feeling good about the direction I took this. At a quick refresher, it looks to me like I don't have a way to show you this. There's not an evaluation. There's not something that I can substitute in here necessarily unless I came up with my own numbers and did some checking. I think we're going to talk about distribution just like my red hour sees. So, all right, here we go. If you've never seen this before, this could be new and exciting. This would be a good reason to be checking this and making some changes. So what I want you to notice is this t plus 4 in the middle. I can't really add them together. I don't know what t is worth. It could be worth 5 or 0 or 7 or 9. I don't really know. So these are just going to stay separate terms is what we call them. This 8 on the outside secretly is being multiplied by everything inside parentheses. This is called a distribution. And I guess if I think back to one of our early units, actually I believe it was chapter 1, we had to factor out the GCF. It's kind of like saying 8 was the greatest common factor. We're going to put it back inside, back on these terms. So 8 groups of t, maybe you can picture it. T 8 times. Well, how many t's do we get? Looks like we get 8 of them, so we actually call that 8t. Next, we have multiplication happening between the 8 and the 4. This distribution in front of parentheses means everything inside gets multiplied. So 8 times 4 gets me 32. There was addition, there's still addition. This is really my target. This is really what I'm shooting for. I want everything to be equivalent here to 8t plus 32. Well, let's do some checking. Are there any answers that already stand out at you? I hope you'd say yes. I actually see 8t plus 32. There's one possibility. But notice it says select all the expressions that will work. So let's take a look at something else. How about the first one? What's happening between these parentheses and the 2? Notice that's a multiplication or a distribution again. So if I were to expand this, I would say 2 times 4t, or 2 groups of 4t. Oh, here's a group of 4t's, and here's a group of 4t's. That gets me 8t's altogether. Well, what's 2 times 2? That would get me 4. And if there was addition, there's still addition. Does this one check out? The answer is no. This is a bad choice. Looks like I got 8t, which was similar, but that last number, which we actually call a constant, doesn't have a variable on it. It does not match 32. Let's take a look at another. Well, this third option. Do you see how I have t's and more t's? If I had 4 t's, oh, that looked just like this, wouldn't it? And I added 4 t's to it. I could put those together and call them 8t. This is the same as 8t. But this 4 can't really go with anything because it's called a constant. He's kind of lonely. He's constantly alone. He doesn't even have a variable term. Well, I got the 8t that I was looking for. That's awesome. But look at this 4 compared to 32. They're not the same amount. This is another bad choice. All right, well, how about this next one? They tell me I have this group of 8 plus t, another group of 8 plus 4. Well, I can't really add the 8 and the t together, but I could add the 8 and the 4 and get 12. Let's think about this. If I took off the parentheses, because they're not showing me any multiplication, there's not a distribution out front, is there? No factor to put back in. I could add 8 and 12. Those go together. They're both constants, and I would get 20. But there's just this lonely t over here, all by himself. Just one t to show. That's definitely not looking like what I'm shooting for. I don't see 8 t's. I don't see a 32. It's not going to work. Oh, and then there was this last choice. Let's take a look. Well, I could read this as 8 times t, or 8 groups of t. Okay, I saw that a minute ago. 8 groups of t. There's 4 groups. 8 groups of t. Oh, you know what? All those together gets me 8 t's. Well, then over here, I notice I can actually do this multiplication inside parentheses. What is 8 groups of 4? Well, that's like we wouldn't typically show it this way, but I could count for 8, 12, 16, 20, 24, 28, 32. If I were to total up those 8 groups of 4, I'd get 32. Notice there's addition happening between those, so I have to put addition here. I noticed something. This looks like a good possibility. I have 8 t's when I'm done. That's what I was shooting for. And I have 32, meaning this constant of 32 matches. This looks like a decent answer. In fact, for this problem, there were 2 good answers. I did not ask you for tools on this one, but I would encourage you to write down something about distribution. So maybe we write down the word distribution. That means that when there's a number in front of parentheses, I get to multiply. Secretly, there's multiplication happening there. All right. This ends our MSTEP setB warm-up for this week. Hopefully you've made some good changes along the way. I learned a few things myself along the way that you should probably preview this before you start your video. And make sure your name, date, and hours on here before we turn it in to give you some good credit